Hello students, in this video we will discuss about the topic of projections of lines. So earlier we have done projection of points. What is the difference between projection of points and projections of lines? The only difference is that the object has been changed from a point to a line now. It is a line. Then the line has its own properties. Point was dimensionless. Okay, so it does not have any property like if you view it from any direction it will be a point only. But in case of a line, since it has length and it is one dimensional object, so you view it from any direction, it will be either inclined or it will be parallel, or it can be perpendicular to any of the principal planes. So there are three basic requirements to draw projections of lines. Let us discuss those requirements. The first one is the length of line is given to you in the question. The length of line should be given to you. Second is the distance from HP and VP. The distance from HP and VP also should be given to you. And the third is the inclination or orientation. I am writing orientation of line with respect to HP and VP. This should also be given to you. So what is this orientation with respect to HP and VP? So it means whether the line is parallel or perpendicular or inclined to any of the principal planes. So that should also be given to you. So in the question you should find out these three options. Okay, so these three requirements should be there in the question. Okay, so if these are there you will be able to solve the question. So before discussing the various cases of projections of lines, let us assume some representations, so it will be easy for us to draw the various projections. So first one, let us suppose the length of line, let it be represented by small l. Then distance from HP, let it be represented by small h. Distance from VP, let it be represented by small v. Inclination to HP, let it be represented by let it be represented by theta. Inclination to VP is represented by phi, right? So let us suppose these representations and then let us draw the various projections of lines. So I am going to erase this now. The first case is line parallel to both HP and VP. So let us see how can it be inclined to both HP and VP. So we will be just discussing this in the first quadrant. Okay, let us suppose this is VP, this is HP. Okay, and this is the line, this is line AB. Let us suppose this is A and this is B, the other end is B. So if I want to draw the projections over here, okay, so if this is the line, this is parallel to both, this is parallel to HP also, this is parallel to VP also. Okay, it is like this. Right, so it will be parallel to VP, so the projection will be like this. Okay, it will be parallel to HP, the projection again it will be like this. Right, so this distance will be how much it is above HP, and this distance will be the distance from VP, or how much it is in front of VP. So here also you will get a line like this parallel to XY line, and here also you will get a line which is parallel to XY line. So if I draw this, it will be like this is the XY line. Let us suppose this is the XY line. This is the front view of the line. So if it is the front view, line is AB, so it will be A dash and B dash. Let us draw the projection lines after this. So none of the projections are possible without drawing the projection line. So always draw the projection line once you draw any of the views. This is the XY line that is completed. So this will be the top view, this will be AB. So here the line joining, or you can say the line of intersection of the projection line and the XY line, this can be represented as A naught, and here it can be represented as B naught. Now what is this? This is, let us suppose this is equal to H, distance from HP, then distance from VP. For now I am just erasing this. Distance from VP, it is V, as we had written the representations earlier, and this will be, I am writing B naught here inside this figure, and this is L. This is equal to L, the length of line. The length of line is also given to you. So this is the first case when the line is parallel to both the principal planes. So like this you will be drawing it. It is parallel to HP and parallel to VP. So both the projections, the front view and top view, both will be parallel to the XY line. Right, so this is the first case. Let us see the second case. The second case is when the line is perpendicular, line perpendicular to one and parallel to the other, perpendicular to one principal plane and parallel to the other principal plane. So I am writing principal plane like this. perpendicular to one and parallel to the other principal plane. So this will have two cases. First case is, let us discuss the two cases separately. First case is parallel to HP and perpendicular to VP. Perpendicular to VP. So this is the first case. So let us see the physical demonstration for the first case, line parallel to HP and perpendicular to VP. So again we are considering in the first quadrant only, right? So line parallel to HP. So this is HP, this is VP. Okay. So you can see, like this was the previous case that we had done when the line is parallel to both HP and VP. It is parallel to VP also, it is parallel to HP also. But we have to make it perpendicular to VP. So you can just rotate it like this. So this will be the position when the line is parallel to HP and perpendicular to VP. It is perpendicular to VP. Okay. So it is parallel to HP and perpendicular to VP. So like this it is represented, right? So if this is A and this is B, okay, so when you view it from the top, it will be a line which is perpendicular to the XY line that is visible to you, and when you see it from the front, it will be just a point. It is when you see it from this direction, from this point, it will be just a point that is visible to you in the front view. Front view will be a point and the top view will be a line. So here there is one more rule that we follow. We draw that view first in which we are able to see the actual length or true length of the line. Let me just write down this rule once. Draw that view first in which the actual length or true length of line is visible. Okay, so you draw that view first in which the actual length or true length of the line is visible. So in this case, when it is perpendicular to VP and parallel to HP, the actual length is visible from the top. Okay, from the top the actual length is visible, so we will draw the top view first and then we will proceed for drawing the front view. Let us draw it for the first case. So the XY line first, we will draw the XY line. Next is, let us draw the line. So this is the line when it is parallel to HP and perpendicular to VP. Okay, so let us suppose this is small a and this is small b. Draw the projection line. Draw the projection line. So front view will be just a point, single point. So when you view it from the front, let us suppose this is, if this is VP, this is A and this is B. So when you view it from the front, A is visible first, then comes B. Okay, therefore you will name it as, the front view I'll name it as A dash B dash. Okay, I'll name the front view as A dash B dash because A comes first, then comes B. Right? So it will be A dash and B dash. And we will name like this is L, let us suppose, length of line. This is distance from VP. This is distance from HP. H, small h, and this is V, distance from VP. So this is the first case when the line is parallel to HP and perpendicular to VP. Okay. So next case is when the line is parallel to VP and perpendicular to HP. Okay, so this rule again we will follow in this second case. So I am erasing this now. So let us see it physically. So again the line is parallel to VP and perpendicular to HP. So it is like this. It is parallel to VP and it is perpendicular to HP. Okay, so here in this, which view we will be drawing first? We will be drawing the front view, because in the front view I am able to see the actual length of the line, and when I see it from the top, it is just a single point that is visible to me. Right? So I'll draw the front view first and then I'll draw the top view. So here I am naming this lower point as A and the upper point as B. Okay, just for the matter of understanding. So this is A and this is B. Let us draw. We'll draw the front view first. So XY line. Let's draw the front view. Let us say this is the front view. Let us draw the projection line. Let us say this is the projection line. So if I suppose that this is A and this is B, so the front view will be A dash and B dash. So accordingly, since this is A and this is B, okay, so when you see it from the top, when you view it from the top, B comes first, then comes A. Okay, B is visible first, then comes A. So I will name it as, the top view I will be naming it as BA, not AB now. It will be BA, right? So rest, it will remain the same. This is length of the line, L. This is distance from HP. And this is distance from BP. So this is common, so this will remain the same. Right, so I suppose this is also clear to you. Line perpendicular to one and parallel to the other principal plane. So this is the second case of projections of lines. Let us discuss the third case, when the line is inclined to one of the principal planes and parallel to the other. The third case is line inclined to one and parallel to the other principal plane. Inclined to one and parallel to the other principal plane. So here also like two cases will be there. So it is inclined to one and parallel to the other. So inclined, let us suppose the first case is inclined to HP and parallel to VP. Okay, so if it is inclined to HP and parallel to VP, this is the case when it is parallel to both the principal planes. So inclined to HP, it will be like this. This is inclined to HP and it is parallel to VP. Like this it is there. So you will draw the front view first, because in the front view you are able to see the actual length. But when you are viewing it from the top, okay, so when you are viewing this from the top, okay, it will be the shortened length visible to you. Okay, it is like this. When you see it from the top, a shortened length will be visible to you. So, or you can say it will be the apparent length, okay, which appears to you, but it is not the actual length. Actual length will be visible when it is parallel to VP, or in the front view, the actual length will be visible. From the top, the apparent length will be visible to you. Right? So let us discuss the first case. Line inclined to HP and parallel to VP. So the first case is inclined to HP and parallel to VP. So as we have discussed, it will be like this. So the front view we will be drawing first and then we will draw the top view. So let us draw the XY line first. Let us say this is the XY line. Capital X, capital Y. So line inclined to HP. So I'll draw this by the actual length of the line. Right? Let us suppose this is A dash, this is B dash. Okay, this is the front view. This angle is theta. This will also be given to you in the question. This angle is theta. Inclination to HP. So it is standard. We consider the inclination to HP as theta. And let us draw the projection lines, vertical projection lines. From here also. Right? So when you see it from the top, the apparent length will be visible to you, right? The apparent length will be visible and the actual length will be visible in the front view. So let us draw the top view. It is not, just a minute. is the top view. This will be small a, this will be b. So rest again it will remain the same, but in this case distance from one of the corners will be given to you. Like here, distance from A we are considering, this is H, distance of A from HP is H, distance of A from VP is small v, this is V, right? Then this is L again, length of line. So the length of line, the actual length of line will be visible in the front view, and this will be the true length. Okay, this will be the true length. So you represent it by, you can write it as TL, we call it as TL, true length. So this is true length, right? Then the second case is line inclined to VP and parallel to HP. Inclined to VP and parallel to HP. So let us see the physical demonstration. So again I am considering first that when it is parallel to both VP and HP. So in this orientation it is parallel to both. So how can it be inclined to VP? Let us, it is like this. It is inclined to VP like this, or it may be like this also. Okay, in either of the directions you can take, or according to the question, whatever is given to you. So it is inclined to VP and it is parallel to HP. Just see, this is parallel to HP and it is inclined to VP. Parallel to HP, inclined to VP. Right, so like this you have to draw. So in this case, which view you will be drawing first? You will be drawing the top view first, because the actual length of the line will be visible from the top, or the true length of the line will be visible from the top, and from the front you will be able to see the apparent length, because it is like this. Let us say if this is VP, it will be like this. View it from the front, it will be the apparent length, shorter length that is visible to you. So you will draw the top view first. With the projections of the top view, you will draw the front view. So front view cannot be drawn directly. So I'll draw the top view first. So it is inclined to VP. Let us suppose this is the line. So this will be, let us suppose this is A, this is B. So from here you draw the vertical projection lines to draw the front view. Like this you will draw. So this will be the front view. This is A dash, this is B dash. Again here also the distance from one end will be given to you. Let us say it is H, this is H, this is V, distance from VP, right? This is phi. Inclination to VP is represented as phi, and this is the length of line, the actual length of line. Okay, and this is the true length. We also call it as true length. Right, so this is the representation for the line when it is inclined to VP and parallel to HP. So I suppose these three cases are clear to you. So we'll discuss one more case in the other video when the line is inclined to both the principal planes. Right, so for that there are two methods, rotational method and trapezoidal method. So we'll discuss those methods also. Okay, for now, thank you very much.